Hello everyone, myself Swapnil Ambekar. I am working as an assistant professor in Department of Mechanical Engineering at Sandeep Institute of Engineering and Management, Sandeep Foundation, Nasik. I have total 8 years teaching experience. I am here to explain the subject metrology and quality control. So, in this lecture, we are going to cover introductions to subject, course objective, course outcome, syllabus, introductions to metrology, inspection, and classification methods of measurements. So, our very first point is course objective. So, students are expected to learn, select the suitable measuring instruments, gauge, method of inspections for determining the geometrical dimensional measurement, calibrate the measuring instruments, and also design the inspection gauges. The next objective is to understand the advances in metrologies such as use of CMM, laser, machine vision systems for the metrology, etc. The next objective is to select and apply the appropriate quality control techniques for given applications. Select and apply the appropriate quality management tools and suggest the appropriate quality management system, that is QMS system. Now course outcomes. On the completion of course, students will be able to, very first outcome is to understand the methods of measurement, selection of measuring instruments, standards of measurements, carry out data collection and its analysis. Second outcome is explain the tolerances, limits of size, feeds, geometric and positioning tolerances and gauge designs. Then third outcome is understand and apply the quality control techniques, statistical tool appropriately. And last outcome is to develop an ability of problem solving and decision making by identifying and analyze the cause for variation and recommend suitable corrective actions for quality improvement process. Now, before going to start our unit number first, we will see here the course content of the course. Our unit number, this course contains the 6 units. Very first 3 units are related to metrology and last 3 units are related to quality control. So unit number 1 is measurement standard and design of gauges. This unit is divided into majorly 3 parts. First one is introduction, second one is geometric form measurement and design of gauges. Unit number 2 is comparator, thread and gear metrology, surface roughness measurement. Unit number 2 is basically divided into again major 4 parts. Comparators. So in comparators there are different types of comparators which are majorly used in industries. We have to understand the working principle of comparators, then measurement of thread form, then gear metrology and surface roughness measurement process. Now unit number 3 is advances in metrologies. So this unit is again divided into major 4 parts: coordinate measure machine, that is CMM machine, then machine vision systems, interferometer and laser metrology. Then remaining 3 units are related to quality control. So unit number 4 is introductions to quality and quality tools, in which the concept of quality, importance of quality deployment at design and manufacturing engineering. Now unit number 5 is statistical quality control. This unit is divided into 2 parts. First one is statistical quality control and second one is acceptance sampling. And the last unit of quality control is total quality management. Again, in this unit we are going to cover TQM, that is total quality management. So under TQM there are different philosophies, different methods are used to improve the quality of the product, to reduce the wastage. Then quality management system, that is QMS system, and need for quality management systems. So these are the 6 units of our course. So our unit number 1 is measurement standard and design of gauges. So Before going to start our unit number 1, we need to understand the meaning of our subject. So that is metrology and quality control. Metrology is nothing but it is a deals with the study of science, that is measurement science. We have to study the measurement science. We know that every industry's the base is measurement, inspection, quality and quality control, right? We have to manufacture a quality control. We have to manufacture a quality product according to the requirement of customers, right? So for that process we have to implement the proper inspection process. So if we need to implement the proper inspection process, for that process we need to implement the proper metrology process there. So metrology is nothing but it is a measurement science process. Then quality control. Quality control is again divided into two words. First one is quality and second one is control. So quality is nothing but what here? Quality is nothing but satisfaction of the customers. We have to prepare the product according to the need of customers, according to the specification of customers. And to achieve that quality, we have to implement some feedback system, controlling system. So while we are going for the manufacturing of a quality product, if we observe some errors, deviation, defects, so we can find out that defect at a particular time, and then we have to take the corrective actions to solve the problems, so we can reduce the defect and we can improve our quality process there. So such kind of system is known as a quality control process. So it is a one kind of closed loop system, feedback systems. So due to that we are achieving our zero defect product, or we are trying to minimize the errors, deviations in the product, right? So that is related to our quality control process. Now let us start our unit number 1. So introductions to metrology. Metrology, it is derived from the Greek word such as metro means measurement and logy means science. So metrology means science of measurements. Engineering metrology, measurement expressed in linear and angular measurement terms. In practical application, it is enforcement, verifications and validations of predefined standards. As we know that while we are going for the manufacturing of any component, if you are producing any component, so first of all we have to set the standards for that component, and according to that we have to work the all processes. So that's why I'm talking about here in practical application, it is enforcement, verification and validation of predefined standards. Now this metrology is also concerned with industrial inspection and its various techniques, units of measurements and their reproduction in the form of standards, ascertaining the uniformity of measurements, then developing methods of measurements, analyzing the accuracy of methods of measurements, and then establishing the uncertainty of measurement, and last point is investigating the cause of measuring errors and subsequently eliminating them. Now the next point is inspection. We know that inspection is a part of our metrology measurement process. So in engineering activities, inspection involve the measurements, test and gauges applied to a certain characteristics in regard to an object or activity. We know that suppose we are going for the manufacturing of our product, any part, any component, so right from the raw material selections to the product delivered to the customers, so there are several processes or comes. So we have to implement the inspection to each and every steps, so we can achieve our quality up to high level, so we can satisfy the customer. We can satisfy the customer according to their need, according to their specification. So for that process, inspection plays very important role to achieve our target and to achieve the zero defect product. So for that process we have to observe it, we have to take the observation very carefully, and we have to note down that all observations on the paper by using some measuring instruments. Then we can take the corrective actions over that observations if some errors are found there, right? So that plays very important role to achieve the quality product there. So that's why it is very important to everywhere. Now the need of inspections, we know that there are some parameters. Based on that parameter we are going to say our quality of our product. So very first point is quality output. How much quality output we are going to get there, how much input we are providing, and according to that how much output we are going to get here. So it is depends upon your kind of inspection process which is implemented meanwhile processes. Second one is change in technologies. Third process, mass of production. So if I'm talking mass production systems, so it is not possible to inspect, measure each and every component during mass production system because it is a time consuming process. So for that process we are using some sample inspection techniques method, and with the help of standard gauges we can also inspect the product, so we can reduce our time of inspection process there. Then save money. We know that if you are doing there is a one slogan that is do the right thing at a right time. We know that inspection is a process if you are doing at a right time at a right place, so we can reduce the defect. Or suppose if we manufacture a component and that component is delivered to the customers, so we have to provide additional facility to that customers if we found some errors, right? If that customer is sufferer of the product, so we have to provide additional service to the customers to resolve the problems. So means what, we have to spend more money if you are not following the proper inspection methods, so again we have to rework there. So every times we need to spend the money over that product there. So if you are using the proper inspection techniques, if you are using the proper measurement system there, so we can save our money on the investment and we'll get the good achievement on the products there. Now next one is interchangeability, and last point is to develop the reputations. Now we know that how to develop the reputation of the organizations. So for that process I am considering here the two examples. One is made in China product and second one is made in Japan product. So everybody knows that everybody needs a quality product, everybody needs a world class manufacturing system there. But what about the customer point of view? They need a quality product at a Chinese cost, but how we are going to get the this output? So for that process everybody is working only on the quality. If we are providing the quality of product to the customers, so definitely we can maintain our reputation in the competitive uh, in the competitive, you can say in the competitive part of our market conditions there, right? Then next one is objectives of our measurements. So now very first objective is it is used for the selection of proper measuring instrument, it is used for deciding the proper measuring standards, it is used to for minimizing the cost of inspection. Then next one is maintain accuracy and precision at the time of inspection, determining the process capabilities, then decide and find the tolerances, achieve the standardizations. Then next point is classification methods of measurement. So there are different methods are used for the measurement. Very first method is a direct measurement, second one is indirect measurement, fundamental measurement, comparison measurement, null method measurement, deflection measurement, then contact measurement and contactless measurement process. So let us see here one by one. First one is direct measurement method. So in direct measurement method, we are directly going to measure the dimensions of the component, or we are going to get output directly according to whatever the standard measuring instruments are used. Here is a simple example is given. Suppose we have to measure the liquid, so we are using some standard liquid measuring device here. That liquid is poured into that measuring device, so you can observe the level of that liquid, and the vertical scale is shown to that the reading of our output, right? So such kind of measurement systems are comes under the direct measurement process here. Second is indirect measurement. So many time it is observed that we have to implement the trigonometry formulae, we have to implement some theorems, we have to implement the um, any kind of methods, so we can find out the whatever the values are unknown there, right? So such kind of methods are consider as an indirect measurement process there. Now fundamental measurements. So in fundamental measurements, so there, here is a simple examples is given to. We have to measure our length in inch, yard, meter, kilometers. So for that process we have to use the conversion factor there, conversion ratios there. So that is nothing but the fundamentals which is required, that is the basic fundamentals which is required for your output to convert one form into another form. So such kind of measurement process are considered under the fundamental measurement process. Now next one is comparison measurement. We are comparing the component dimensions or weight of the component according to a standard. So standard is nothing but that can be universally acceptable things. So we can accept that all the standards, according to the standard we are going to measure the component which we have to manufacture or which we have to buy the, right. Suppose we are talking about a simple example of a grocery. If you are going to buy some groceries, some vegetables in the market, so we are using the, this is very simple measurement techniques we are using, that is comparison measurement techniques. Now next one is null method. So we are finding the unknown factor with some standard values, right. Such kind of methods are known as our null method measurement techniques here. Now deflection method. So a simple example is given here. One spring loaded machine is used here. You can see here the spring pulled spring is attached to our pointer, and this pointer is connected with the whatever the standard readings are given on the vertical scale here. The object is held by using this hook here. So what happened, the whatever the weight is going for the downward direction, so due to that the deflection is formed here, and the pointer is going to move from zero positions to the according to the weight of our object. So it shows the exact dimensions, exact reading, exact weight conditions of the our component and object. So such kind of systems are known as a deflection measurement system here. Now next one is contact measurement system. So in contact measurement systems, we know that we are using the different measuring instruments. So that measuring instruments is directly get the contact with our object, with our measuring component. So such kind of systems are known as a contact measurement system. So in that we are going to get our directly output according to our measuring instrument, right. So such kind of systems are known as a contact measurement system. Then contactless measurement system. So here the contact of our workpiece and measuring instruments, we are not using any kind of contact between the workpiece and measuring instruments. So we are using some advanced technologies like sensors, lasers, interferometers. So in that case we are going to get the output. We are converting input in the form of output, and we are going to get our readings, our dimensions by with the help of that advanced measurement technologies there. So such kind of systems is known as our contactless measurement process here. So I hope you understand all the topic which I have covered in our lesson number 1. So see here the summary of our lesson 1. In this lesson we have learned introductions to metrology and quality control, course objective and outcome, inspection process, and classification methods of measurement. So thank you.